What if Earth isn't rare at all? What if it's simply the last planet in our solar system still holding onto oceans, air, and life-friendly conditions? Scientists now say being Earth-like may not be a special status. It may be a phase, and several worlds around us might have already passed through it. For a long time, people believed Earth was a miracle, a perfect accident, a 1 in 100 billion kind of world. It had liquid water, a protective magnetic field, moving plates under its surface, and just the right temperature for life. But new research is changing that story. Scientists are now saying that Earth-like planets may not be rare at all. In fact, they may form around almost every star under the right conditions. That means Earth isn't a cosmic unicorn. It may simply be one example in a very long line of planets that once looked just like it. And here's the part that really grabs your attention. Planets don't stay Earth-like forever. They pass through it. A world can have oceans, thick air, internal heat, and even a magnetic shield that protects it from space radiation. But over time, those features can fade. The planet cools, the magnetic field weakens, the atmosphere escapes, water disappears. Being Earth-like might not be a permanent identity. It might be a stage in a planet's life. Earth-like worlds may be everywhere. Scientists used to think that planets like Earth were extremely rare, maybe one for every 100 stars. But updated computer models with better physics and geology show something surprising. If the right materials are present, iron, rock, and radioactive elements, rocky planets form naturally. Internal heat builds up, magnetic fields appear, liquid water becomes possible. Instead of one Earth for every 100 stars, scientists now believe there could be one Earth-like world per star. Our galaxy, the Milky Way, has at least 100 billion stars. Suddenly, the universe doesn't seem so empty, and planets don't even need oceans on the surface to count. Some worlds that look frozen and lifeless from space may hide warm oceans deep under their crusts. Heat trapped inside keeps water liquid below thick layers of ice. In our own solar system, moons like Europa and Ganymede orbiting Jupiter likely have massive saltwater oceans beneath their icy shells. Around Saturn, Enceladus sprays water vapor from cracks near its south pole. Even distant dwarf planets like Pluto show signs that liquid water may exist underground. The secret is heat. Radioactive elements inside planets slowly release energy. It works like a tiny heater that never switches off. On top of that, gravity from nearby giant planets can stretch and squeeze smaller worlds, creating friction heat inside them. Water plus heat equals possibility, and that combination may be far more common than we once thought. Our solar system's former Earths. Now let's bring this closer to home. In the early days of the solar system, 4 rocky planets formed close to the Sun: Mercury, Venus, Earth, and Mars. They formed from the same cloud of gas and dust. They had similar ingredients. Exploding stars called supernovae scattered heavy elements like iron and nickel into that cloud. Those elements allowed rocky planets to develop solid cores. Solid cores create magnetic fields. Magnetic fields protect atmospheres. Atmospheres support water. That's the starter kit for an Earth-like world. So instead of Earth being a miracle, it may simply be the survivor of several attempts. Let's look at the others. Mars. Today, Mars looks dry, dusty, and cold. But it wasn't always that way. Scientists have found clear signs that Mars once had rivers, lakes, and possibly even a massive ocean. There are river deltas carved into the surface. Minerals that only form in water have been detected. Landscapes look shaped by flowing water rather than impacts. The big question used to be, was Mars briefly wet, or did it have long-lasting oceans? New evidence suggests something dramatic. Around 3 billion years ago, Mars likely had a huge ocean covering much of its northern hemisphere. Not just scattered lakes, one connected body of water. One clue comes from the largest canyon system in the solar system, Valles Marineris. It stretches over 2,500 miles long. Inside parts of this canyon, scientists found layered deposits that look like ancient lake beds. These deposits all sit at nearly the same height. That tells scientists the water level stayed stable for a long time. In some areas, water depths may have reached more than 3,000 feet. And here's the critical detail. The canyon floor sits higher than Mars's northern lowlands. If water filled the canyon that deeply, it must have spilled outward, flooding the northern half of the planet. Mars may have once been blue. So what happened? Size mattered. Mars is smaller than Earth. Because of that, it cooled faster. As its core cooled, its magnetic field weakened. Without a strong magnetic field, the solar wind began stripping away its atmosphere. Once the atmosphere thinned, water could no longer stay stable on the surface. It slowly escaped into space or froze underground. Mars didn't fail because it was strange. It simply aged faster. Venus. Then there's Venus. Today, Venus is incredibly hot. Hot enough to melt lead. Its air is thick and full of carbon dioxide. The pressure on its surface is crushing. It looks like Earth's evil twin. But older data from Magellan, a NASA mission in the 1990s, tells a more interesting story. Magellan mapped Venus in detail. At the time, scientists focused on counting craters and mapping strange landforms. But with better technology today, researchers are re-examining that data. And they found huge circular features called coronae. These look like giant blisters on the surface. They form when hot material from deep inside pushes upward. Venus doesn't have moving tectonic plates like Earth, but it may still have powerful mantle activity beneath its surface. Rising plumes of hot rock could be reshaping the planet from below. Some scientists even think Venus once had oceans, and possibly for billions of years, before a runaway greenhouse effect heated it beyond control. If that's true, Venus may have once been Earth-like. It just crossed a tipping point, and NASA's upcoming Veritas mission aims to map Venus again with much sharper radar. If Venus is still geologically active, we may soon know. Studying Venus could be like looking at Earth's past or its possible future. Uranus. Even the outer planets are getting second looks. In 1986, Voyager 2 flew past Uranus. The data confused scientists. Uranus's magnetic field was tilted and off-center. Its magnetosphere looked strange and weak. Scientists assumed Uranus was permanently unusual, but recent studies suggest something different. Voyager 2 may have flown by during a powerful solar storm. That means we might have seen Uranus during an unusual moment, not its normal state. If that's true, then our understanding of Uranus is based on a brief snapshot taken during bad space weather. It reminds us of something important. Planets are dynamic. They change, and sometimes we only catch them during certain phases. Earth, the last one standing. When you put all of this together, a new picture appears. Mars may have been a blue world with oceans. Venus may have had water before overheating. Icy moons hide oceans beneath frozen shells. Even distant planets may have once been warmer. Scientists are starting to say something bold. Earth is not a planet type. It's a phase. Planets can pass through an Earth-like stage. They can have water, air, heat, and protection. But those conditions may not last forever. Earth just happens to be the one still holding on to them. For now. That realization doesn't make Earth less special. In fact, it makes it more precious. If other worlds lost their water, their air, and their protection, it shows how delicate that balance really is. Earth's magnetic field still shields us. Its core is still hot. Its atmosphere is still thick enough to support life. Its oceans still cover most of its surface. But planetary history tells us one clear lesson. Change is constant. The solar system may be full of former Earths, and understanding their stories helps us protect our own. Earth might not be the only world that ever looked like home, but it may be the only one left that still does. If you found this fascinating, make sure to like this video and subscribe to the channel for more amazing science stories about our universe. The cosmos is full of surprises, and we're just getting started.